for the March MSCC All Hands meeting. I'm Leslie Jones, Director of Program Development for MSCC. And along with my other MSCC colleagues, are excited to have you here today with us so we can provide more opportunities and learn more about different things that are available to you. First, as we normally do, if there's anyone that this is your first time joining us, can you just go ahead and introduce yourself? All right, so I'm going to assume that everyone who was on the call has been on this, who's joining us today has previously been with us. All right,
Hello.
so
Yeah, I'm
go
new
ahead.
too.
All
I
right.
apologize. My name is Marisha Towner. I am a undergrad from Fort Valley State University, and I am pleased to be in attendance with you all today.
Well, I'm glad to have you. We love to have students join us. Thank you. Is there anyone else who is the first time on our call?
Sure. My name is Natalie Palmer, first time on All Hands Call. Hi, Leslie and others. I'm with the SOX, Southern Crossroads Research and Education Network.
And thank you for joining us today, Natalie.
And I believe this is my fourth time. This is Yolanda Puppo from Hampton.
All righty.
And I'm Ray. This is my first All Hands. I'm the newly hired MSCC Assistant Director for the Climate Science Program. So happy to be here on the team and look forward to getting to know you all.
And thank you so much for introducing yourself, Ray. My apologies for not doing it for you. She is our new colleague, and we are excited, just as excited to have her as she is to be with us and focusing on our climate science initiative and working with our students. So we have a couple of things upcoming that I want to make sure you are aware of. First, we have a workshop that is going to be taking place next week at Prairie View A&M University, April 3rd through 4th. So if you are one of our, if you are representing a a Texas HBCU, or if you are from Southern University of Shreveport, you're in our 250-mile radius, we would love to have you come join us next week. Registration does close tomorrow. So if it's something that you are interested in attending, our in-person workshop to talk about cyber infrastructure and collaborating with other HBCUs in your region, it's a perfect opportunity for you to do so. So join us. Of course, it is free, as all of our events are free for you to join. Then we also have an event coming up at Virginia Union University in Richmond, Virginia. So those of you who are closer to Richmond, we have that coming up. Stay tuned for more details. It will be after our annual meeting in May, which is our next announcement. We have our second MSCC annual meeting taking place May 29th through 31st this year at the Mayflower Hotel in Washington, D.C. As usual, it is free. Registration is open. Their travel support is available if you represent if you are an MSCC participant from an HBCU or a TCU. We are going to be focusing on our 3 tracks of climate science, research, and campus technology and leadership. Proposals have been submitted. We're going to be sharing more information about that as we go along in the coming days, and we're excited about it. So we hope you're excited too and will join us. Go ahead and register for it. If you're not able to use the QR code right now, you can go on our website and get information and submit your registration that way.
Leslie, I don't mean to interrupt, but he's on, and also just the heads up, he's under Laura's account.
Okay.
So he will so he's ready whenever you are.
Okay, thank you so much. Okay, so he'll be able to go ahead and share once we get started. I have all the slides just in case there's anything that needs help, but okay. Next, we have an announcement. We don't typically do these types of announcements, but this one we thought we would bring to you because some of you might want to be involved in this activity that's coming up. We have an opportunity for some of you to participate in, if that's something that you decide to do. Mallory Hicks, who is representing the middleware and grid interagency coordination MAGIC, is looking for some people, some experts, subject matter experts who would like to participate in some upcoming workshops they have. Again, it is sponsored by the Middleware and Grid Interagency Coordination Team. Magic was established in 2002 and provides an opportunity for information sharing among federal agencies and non-federal participants, including higher ed institutions, involved in middleware, grid, and cloud research and infrastructure, implementing or operating grids and clouds, or the use of grids, clouds, and middleware. Over the next several months, Magic is planning to hold a series of panel discussions to explore the topic of cloud and on-prem for research. The goal of this series is to produce a white paper to inform the academic industry and government communities on the current state of cloud and on-prem, touching on interoperability, workforce development, and workforce issues, and identifying challenges and opportunities. They want to get perspectives from diverse groups of people. So each month they will be hosting a panel of representatives from a different type of institution. For the first month, they are planning to invite panelists from HBCUs, MSIs, or PBIs. So if you have any questions, if that's something you think you might want to serve, be on that panel, engage in that presentation that they're going to be doing, you can do so. The information is on the screen, hinks@nitrd.gov. So if you think you want to get more information or you might want to participate, send Mallory Hinks an email. And now we're going to go ahead and get started. We have a presentation on Anvil, and a lot of opportunities available there. Our presenters, Rajesh and Susanna, are on our call now, and they're ready to get going and share. So I'm going to let Tinny might have to give sharing permissions to so that Rajesh can get started. But once that happens, we can go ahead and get moving. So Rajesh, just let me know when you're ready to go and take over.
All right, thanks again. Can you hear me?
Yes.
All right, great. Yeah, and sorry about all those challenges.
So I'm going to
I
stop
got put in the
sharing so you
Zoom
can take over.
doghouse and couldn't sign in again, but I'm gonna try sharing my screen now,
Okay.
if that works.
There we go.
Can you,
We see your screen, you just don't have the slides up yet.
oh, do you see them now?
Not yet.
Okay. Let me make sure I have the right, I'm using someone else's computer, so I'm just gonna see if I have the right screen shared. Okay, so this, no, I want to go full screen, so I can use this one, right? All right, I'm gonna try it again, hopefully.
Okay, we can see it. You just have, there we
Yep.
go. Thank
See the
you.
slides now? All right, great. All right, well, I guess with all those technical challenges, thanks again for this opportunity for us to be able to talk about Anvil. There'll be two presenters. I'm Rajesh Kalyanam, Senior Research Scientist at the Rosen Center for Advanced Computing at Purdue University, and we also have Susanna Gardner, who is our outreach coordinator and an administrator of research operations here at the Rosen Center as well. So we'll be tag teaming this presentation here today. So Anvil is essentially a supercomputer at Purdue that's been funded by the National Science Foundation. So I want to first acknowledge their support for this project. We have the award number right there at the bottom. This was funded as part of the Advanced Computing Systems and Services, or ACSS program. And a big part of this is supporting researchers around the country to be able to use this supercomputer who may not have these resources at their other at their own institutions. And so that's essentially our goal for today, to be able to talk about this resource, the features of the resource, and our support for researchers around the US, and how maybe we can help the folks here get onto the system and start using it at their own institutions. I want to start first with the high-level overview of the goals for Anvil. So these are the top three goals for why we proposed the system to the NSF. The first thing is the need for resources. I guess I don't really have to say that here. Everyone knows there's a need for computational resources, especially with the kind of resource-intensive computations that are required now, not just in AI and ML, but other domains as well. And NSF and many folks have been aware of this need for a while. So even with the previous systems that NSF was funding, they were usually meeting a need of like 80% of what researchers wanted, but then there was always a need for more resources. So that's our primary goal here for Anvil. The second goal, like I mentioned, is to support these non-traditional computing paradigms. So it's not just high performance simulations anymore. You might need things like non-batch computing, maybe interactive computing for things like Jupyter notebooks. But then also with AI and ML, there's a change in the kinds of jobs and workflows that you're running. So it's no longer just batch simulations, but you might need to do the whole machine learning workflow. And finally, we also want to expand this use to non-traditional domains. So everyone is being exposed to some aspect of computation now, both in traditional computing, but then also with AI and machine learning becoming more popular. And so for these first-time users and researchers, we want to lower the barrier to be able to use the system. And so part of our goal is to also design interfaces that help with that aspect. And then finally, we don't want this just to be focused to current researchers. We also want to educate the next generation's workforce. And so a significant component of Anvil is also these educational and training programs, training users, but then also the new workforce starting right from K through 12 to undergraduate and graduate students as well. And so, like I mentioned, this is funded through the NSF ACSS program. It's what's called a Category 1 capacity resource. And so the big portion of Anvil is essentially just to support computing capacity, and it's a very large CPU system. It's funded by a 10 million acquisition grant, which is just for deploying the system itself, but we also have funds for operating it for 5 years, at least initially. So we are scheduled to continue operating this through February of 2026. And right here, you see a picture of Anvil in our data center right there. So here's a high-level view of these various components of Anvil, so how it tries to address the 3 different goals I spoke about in the previous slide. So on the top left here is a description of the compute and storage infrastructure on Anvil. So as a capacity resource, it has 1,000 CPU nodes. It was deployed in 2021, so at that time it used the latest generation of AMD processors, which was the 3rd generation AMD Milan. So in addition to these 1,000 CPU nodes, it also has 64 A100 GPUs. So these are 4-way A100 GPUs on each node. So we have 16 GPU nodes, which have 4 A100s each for a total of 64 GPUs. There are some computations that need more than the amount of memory that these nodes might have. So our CPU nodes all have 256 gigs of memory each, but then we also have 32 nodes that have 1 terabyte of memory, so that if you have a really memory intensive job, then it can be run on those nodes. There's multi-tier storage behind the system backing all of this. Some of it is backed up and persisted. Others is scratch storage that you can use for high I/O intensive jobs, but then it gets removed once the job is done. I won't go into many of these other details here, but we are slated to deliver 1 billion CPU core hours per year to our users from these 1,000 CPU nodes. Here in the bottom left, we have a somewhat more innovative piece on Anvil. So in addition to just the regular batch computing, we've also seen that new usage modes like containers and cloud style workloads are also becoming more popular. And so to support that, we have what's called the composable subsystem. I'll get into more details of this in future slides. So I won't really go into this right here, but it's essentially intended to complement the batch computing system and then support new cloud style workloads. Moving on anti-clockwise here to the bottom right. So on top of all these compute hardware, we have a comprehensive set of software. So it includes most of the typical HPC codes and compilers that you can think of, but then also other software solutions for like data science and machine learning applications. And as part of lowering the barrier, we have these various interactive interfaces that you can use to essentially access the system from a web browser instead of having to actually log in and use the command line. So I'll talk about that in a little bit soon. And finally here, on the top right is, I think, probably the most important part, which is training the future generation workforce. So a significant component of the Anvil project is providing user support and training. both for current users, but then, like I said, also training the future generation workforce. And we have a whole CIXP student apprentice program. And part of that is our REU program, which is the research experience for undergraduates, which I'll talk about again in a little bit. So as an NSF system, Anvil is free to use for researchers and instructors around the US, but then access to Anvil is managed through this other NSF program called Access. Access, some of you may be familiar with, it used to be called Exceed, which was a system before that was providing these allocations on these resources. So Anvil is one among 6 other capacity resources around the US. And the NSF Access program essentially helps you get access to any of those systems around the US, but then also several other experimental systems as well. So this is essentially a centralized system for getting access to these resources. Typically, there are 3 steps, which you can see here on the right. First is you sign up for an Access account. You figure out the amount of resources you need, which puts you into certain tiers. You apply for credits, wait for it to get reviewed. And then once that's reviewed and you're approved, then you can exchange credits for use on these various 6 different resources. So you're allocated a pool of credits that you can then choose to use on any of these NSF funded resources, depending on which one is the most appropriate for your research use case. And then you can self-manage your allocation, add users to it, add students, and then finally log in and run your code. A big part of our support activity is to actually get you onboarded to the NSF Access system, because I think that's the big part that's really a big barrier for users coming in. And you'll hear more about this when Susanna talks about our experiences with onboarding users in the second half. I'll just take quickly on the various allocation tiers. In Exceed before, typically you had to be a postdoc or a faculty or a researcher or an instructor, but now Access also allows graduate students to be PIs on these allocations. So the first tier, which is the Explore tier, actually allows you to be a PI on it, even if you're a graduate student who's working on your thesis. And so a significant number of allocations that we've seen, actually a third of our allocations is from such graduate students who are working on their PhD theses, who are actually on Anvil at the moment. So here at the bottom, you see 2 links. One is our documentation on how you can get onto Anvil through this access process, and then also the link to the access allocations page. But I'll be happy to answer any questions about this towards the end as well. So moving on really quickly to scientific applications on Anvil. I'll run through these really quickly just to give you a flavor of the things we have currently supported on Anvil. So first, here's a big overview of the typical application stack we have on Anvil. So we have most of the common programming libraries, both the GNU, Intel, and AOCC compilers, different MPI libraries. On top of that, we have various scientific applications, so both the general purpose math and modeling tools, but then also certain domain-specific tools like molecular dynamics codes or DFT and other simulation codes like VASP or Quantum Espresso. And then on top of all of that, we also have support for singularity containers and execution. So many codes now have started using containerization for ease of portability between different systems. And this is especially true for the NVIDIA NGC containers, which provide both pre-trained models, but then also other machine learning codes. So we have support for that, but then we also have support for large data sets that we can host centrally on Anvil, that you can then use for your research instead of having to manage them in your own storage. So things like the NCBI database, the iGenomes database, and then also large climate and weather data sets. And then at the bottom here is our application stack for supporting AI. We have the foundation, which is the NVIDIA SDK. On top of that, various popular machine learning frameworks that you might all know. And on top of that, we have things like NGC containers, which can bring in pre-trained models for different use cases. I won't go into too much detail over this slide, but it just shows you the sort of the list of different domain-specific, but then also more general application libraries that are available. Next, I want to talk about lowering the barrier to access. So like I mentioned before, we want to be able to support first-time users to HPC. So we don't want them to have to figure out how to get onto Anvil through their command line and figure out how to SSH and log in and run their jobs. But we want to provide them access through a web browser. And so we have two specific ways of doing this. One is the Open On Demand application. So this is actually a portal framework that was developed at the Ohio Supercomputing Center. It essentially provides interactive access to your supercomputer. So here you can see a couple of screenshots on this. You can actually manage and submit jobs directly through this Job Manager and Composer tool on the on-demand web portal. You can run things like Jupyter Notebooks or RStudio, and then many other interactive apps that you see here on the right, things like ANSYS, MATLAB, VMD, ParaView, and other visualization software. And here's just some quick screenshots on how you go about launching these applications. So you can see here, you can come into this web page after you've logged into On Demand, enter your allocation and other details like the amount of time requested, wait for it to launch the job. Once it's done, then you can just click this button to connect to Jupyter. And then you're up and running with a Jupyter notebook that's actually running on one of the nodes on Anvil, where you can then start running your codes. And we, in fact, have 1,800 students right now who are part of a data mine, data science learning program, who are all using this Jupyter Hub interface on Anvil to be able to do the different data science assignments and projects. Here's a screenshot of the ThinLink, which is the other interactive interface to Anvil. So this actually provides you a complete remote desktop on Anvil. So you can see it. You have the ability to open your terminal, run things like Jupyter and MATLAB again from here. But then this also gives you access to different visualization software like ParaView or Visit or VMD. So once you've run your simulations and your codes, you can then use this to actually visualize the results of the simulations. I want to talk quickly about the composable subsystem, which is one of the innovative pieces of Anvil. So we've discovered that there are some non-traditional use cases which are not just the typical batch computing job. So you might need a customizable amount of, say, CPU or memory, some specific customizable storage. And this is typically used for deploying persistent services like, say, databases or, say, a message broker, or a simple portal or a gateway. And for use cases like this, users would typically go to the commercial cloud. And again, that's a really expensive proposition because you need to pay for the services that you're hosting on there. But then this sort of gives you an alternative to that, where you can deploy containerized workloads, which you would typically do on the cloud, but you can now do it on the subsystem on Anvil. And once you've deployed these applications, then you can automatically publish these on public or private networks for other users to be able to access them. Behind the scenes, this uses the Kubernetes container orchestration framework, and you can again access all of this through a web interface called Rancher, which allows you to customize and deploy these various applications. So I have screenshots of that here next. So this here shows you how you can deploy say a MySQL database. So here you see the web interface of Rancher, which gives you the different applications that you can deploy. So you see things like MongoDB or MySQL. You pick the software you're interested in. You can configure things like the version of the image you want to use, and like the specific versions and things like that. You can set up various configuration options like the settings, the admin settings, and the port number. You can also configure storage. And then finally, specify how you want to expose the database through a public or private IP or DNS hostname. And then once that's done, then it gets deployed using a container, and you can then access it and then start working with it either directly through the Rancher interface or from other applications like, say, Jupyter. So you had a database that was hosted with some data that's ingested into it. Then you can access it from another application like Jupyter and then connect to it and do analysis. I want to talk now about our approach to user support and training. So we have a dedicated team of people who actually work on both of these aspects. So in terms of training, we have both virtual and in-person training that we do periodically. And a calendar of this is usually published on the Anvil website, so you can see what trainings we have coming up. This is again trainings for both current Anvil users, but then also future Anvil users who might be interested in following along. And we also typically record these training offerings. So you can then, if you've missed a training, you can then go back and review the slides and then follow up with that as well. In terms of support, we have a tiered support structure. So we have 3 different tiers. Our first tier usually triages tickets. So we use a central access ticketing system for Anvil. So anyone who has any questions, they can put in a ticket through the access system. It gets triaged by our tier 1 support. Our tier 2 support then provides an initial response. And then if it's really a domain specific problem that you need more domain specific expertise from, then that's where our tier 3 experts step in and help with that. We've also recently instituted what we call Anvil support hours. So this happens every Thursday. It's a virtual meeting on Zoom. So anyone who feels like it's hard to explain over a ticket and they want to actually talk to someone in person, they can actually sign up for. Just gonna grab a sip of water. Yeah, so anyone can sign up for a 20-minute slot every week, and then they can talk to our support personnel there and then try and get their issue resolved through that. Here is a list of the trainings that we've conducted in the past. So you see it spans both introductory topics, but then also advanced tutorials and specific targeted courses for things like GPU programming or workflow automation. And here we have a roadmap for spring of 2024. You'll see that we have both advanced topics like clusters, software installation, but then we also have things that are more exciting topics that people may be broadly interested in, like things like generative AI, quantum computing. And so we've tried to have a good mix of both topic specific to research that people are doing, but then also trying to get ahead of the curve and then introduce people to things that may be coming around the pike and start looking into those applications as well. I want to talk a bit about some of the impact we've had through all of this use on Anvil. So here's a quick look at some of the allocation statistics. So far, we've got a total of nearly 600 allocations in the last 2 years. These span 62 different science domains and nearly 6,000 users, and nearly half of them are actually undergraduate users. So they are students from the data mine program that I mentioned before, and then also other educational and training programs, and nearly 1 billion of CPU hours that have been allocated so far. We've had 24 different training sessions that we've conducted in the last 2 years, and again, a list of several different outreach events that you'll hear more about from Susanna. I want to mention quickly some specific testimonials that we've received from users before I dive into more specific use cases. So most of our users were really happy with the A100 GPUs because it gave them a really good performance boost over the previous generation. And a big factor in that and improving time to science was actually the NGC containers that we have on Anvil. So these users don't have to build their own codes or dependencies. They can quickly get up and running with an environment for using these GPUs to these containers and then start actually deploying their science. And again, you see here, many of these people have been able to really cut the amount of time that they spend on getting up and running through the use of these GPUs. I'll try and go really quickly through these various science accomplishments. So this user here from bioinformatics, again, was doing this end-to-end analysis of genome sequencing data. They were able to get it to run 25% faster on the A100 GPUs. Our next use case here was on computer-aided drug design. They wanted to do really long-running molecular dynamics simulations. Again, they were able to port their code to GPUs and get nearly a 1.48 speed up, x speed up compared to other HPC systems. This user here was really exciting for us. This is actually from physical sciences. So they were trying to study plasma and turbulence. they wanted to move from 2D to 3D, and so they wanted to really scale up their simulations on a large number of nodes, and we were actually able to give them a reservation first on a quarter of Anvil, which is 256 nodes, and then on almost half of Anvil, which is 512 nodes, and then they were actually able to scale their code and run it successfully on the 512 nodes across all of these nodes on Anvil. This researcher here, actually locally here from Purdue, she is studying actually how the host white blood cells interact with pathogens, and then they wanted to study a variety of different initial conditions. And so again, that's a very large parametric space. And so we have a wide queue on Anvil that allows you to run jobs on up to 56 nodes. And they were able to get up and running with those number of nodes very quickly, and then also be able to simulate this at the number of degrees of freedom and parameters that they needed. And this user here, finally, from astronomy, was actually able to do their whole end-to-end workflow on Anvil because of the interactive interfaces that I mentioned before. So they were able to run these simulations for studying the massive star winds for a particular star, I think a binary system, and then they were then able to use Visit directly on ThinLink to be able to visualize their results pretty quickly. So they were able to do the simulation, but then also visualize it so that they could confirm with their own eyes to see if it was doing what they predicted it was actually going to be doing. And finally, I want to also mention this feedback from one of the educational activities on Anvil. So it's not just research, but you also have instructors who are using Anvil for training researchers. So we have this NIH Care workshop, which is actually using Anvil for its third year now. And it's essentially a 10-day intensive workshop where they train cancer researchers on how to use public omics data and then do analysis on top of that using Python and R. And this was really important because they say they don't really want to turn everyone into a computer scientist to figure out how to use these systems. So they want something that's easy to use, that they really don't have to worry about so that they can focus on their actual science. So the user-friendly aspect of Anvil, I think, was a big pull for them, and just helps them from having to sort of focus on getting the compute together and focusing more on the actual content of the workshop itself. And I'll wrap here with talking quickly about our workforce development program, specifically focusing on the REU program. So we've had this REU program for 3 years now. In the first year, we had 2 students, and we grew it to 3 students. And actually, last year, we had 5 students in our Anvil REU program. This is an 11-week program that happens in person over the summer. So these students actually come here to Purdue's campus. We give them essentially space in one of our residence halls so they can reside here on campus. And each of these students have 2 mentors that work with them. So we had these 5 students working on 4 different projects with a total of 8 mentors. They get a stipend of $600 every week, but then we also support their travel and funding to take them to a conference in the summer as well. So last time we had a pretty good representation of students from around the country. And we've actually grown this again in 2024, but I won't focus on that here. I did want to mention that we, in addition to actually working on Anvil and research projects related to that, we also have a set of other activities for them. So they can collaborate with the Summer Undergraduate Research Fellowship Program here at Purdue. We have presentations and workshops by faculty here at Purdue. So for example, we had a presentation on good visualization practices. We had one on AI and machine learning. And other technical presentations as well. And we also funded their travel to the PERC conference, which is the big research computing conference that happens every year. And for all of these students, this was actually their first experience in going to a professional conference. So they really learned a lot from that. They were able to participate in the student program there, which gives them more training opportunities, but then also professional development, things like building their resume and maybe applying for a job and talking to real world full-time professionals there as well. And in addition to working on these projects, they also present their results to the PI team, mentors, and the overall organization. So that also helps them get skills in presenting their work, but then also considering questions they may have not thought about before. And this was really a great result. One of these teams actually wrote up a paper about the work that they did over the summer, and that was actually accepted to the Supercomputing Conference. So that was really a really great accomplishment from these students last year. I won't go into too much detail. I know we might be running short on time. So I just want to say that this is a really holistic program that has not just the technical aspects, but then a bunch of other things like mentorship, buddy systems, and dedicated program administration. And this is open to undergrads all around the US, so anyone can apply for this. I think applications typically open in Jan and go through the end of Feb. And this year we actually had 1,000 applications for this program. Here is some of the feedback from these students. So they all came in with some understanding of research computing, maybe not too much, but then at the end of it, they were able to really gain a lot of skills in how to solve problems, understanding connections, and feel like they fit in with the IT community. So I think
Hello, can you hear me? Rajesh, we lost you. Can you hear me? Anybody?
I can.
Yeah, I
Oh.
can. I'm wondering if the batteries need to be charged on the headset or something, right?
Oh, okay. It's just he has the access. I mean, not access. The he'll be able to click the slides for me because I don't have the.
Susanna, you can go ahead.
Oh, okay. All right. So just a heads up, you'll be clicking for me. So my name is Susanna Gardner, and feels like gonna fly through these slides, but if you have any questions, you're welcome to email us and we'll share these slides for to kind of further the discussion. Next slide, please. Go back, please. There we are. So we'd like to share 3 accomplishments with our efforts. So through our personalized outreach, we continue to establish meaningful connections with broad base of learners and increase our student engagement by introducing them to Anvil and HPC, and hopefully inspire next generation of talents. So one of the most important things, we want to continue recognize the importance of engaging with minority serving institutions and understand better the needs they have and what success means to them and how can we best serve them. Next, please. So this one is as part of our ongoing email campaign over the last several months. We're happy to share that we have successfully conducted meetings with these schools that you see on the screen. We thought this would be the best way to showcase our reach visually. Next, please. One-on-one Anvil onboarding, as Rajesh touched. So we decided that it's not just send them an email and get them on Anvil. It takes time and effort. So we've established this special program to engage with these schools and have sort of a VIP introduction to Anvil and help them acclimate it and answer all the questions. So the schools we've been in contact, William Patterson University, CUNY, John Jay College of Criminal Justice, Xavier University of Louisiana, and many others. So we've conducted one-on-one outreach to build these meaningful relationships. Otherwise, it's impossible just to assume that everyone knows what needs to be done. So we're there for them every step of the way. On the screen, you see Dr. Surreal. He's a professor at William Patterson University. He also teaches 2 classes, data science and analytics. He was invited to the meeting, but he brought, as you see, more than 1, 2, 3, 4 more people for Montclair State University that he does research with. So this was a great one of our first one-on-one Anvil onboarding. So we were super excited. We decided to share that with you. Next, please. Students engagement is another success story. We've hosted over 150 students from various institutions, and we've delivered presentations and tours on Anvil and our Envision Center. Through these engagements, we're trying to raise awareness about HPC and Anvil among middle schools and high schools, undergrad and grad students. So you see on this slide, Girls Who Code organization, are from Southport High School. It's here in Indiana. And they had a wonderful visit last year, and so they're returning this year. So this second photo, you see engineering in a world of data learning community. They're first year students with Dr. Witt. Another photo with Elmore Family School Electrical and Computer Engineering. Oh my gosh, that's a mouthful. So with Dr. Kildashev, and these are grad students visiting Anvil. Next, please. So Laura, also on this call, she is a co-chair of the PERC. She was a co-chair for 2023 student program. Along with other colleagues, we've provided HPC technical workshops for the students utilizing Anvil and introducing broad HPC computing ideas. At the PERC 23, our student program, I think we had 57 participants engaged in workforce development, utilizing Anvil for their project. You see the image of that. Anvil was also highlighted in the in Issues in Science and Technology article, which was a dedicated outreach team from us, which Anvil project is recognized for its intentional outreach and engagement. Next, please. The focused minority serving institutions. I think this is what I learned, that Anvil, to add 10 users on Anvil was a journey that requires patience, teamwork, and really cultivating those relationships and connecting with people. It's not as easy send an email they're on. So it kind of shows on this slide that out of 164 emails, the 8 institutions were in communications with us, and then 3 got allocations, and we got 10 users out of that. Next, please. As Rajesh mentioned, our RU program, we were excited to share our program with 949 schools. And it's on January 2nd, we've initiated this huge outreach effort. And within a few days, we observed 265 new applicants. Our program manager mentioned to us that 70% of the REU program students were from Purdue, and the objective was to reach a broader audience and bring them on board. So once I send this these emails, we got 265 applicants. I know this is not direct. We can guess that's the reason, but we can't 100% say that was the reason. So it was great. We're growing that program and very excited about that. I was quick. So how can we help? So this is our last slide. And also, if you have any questions, we have 10 minutes. We're happy to answer them, Rajesh, right?
Yes, yeah, and I'm sorry, we probably took more time than we intended, but I wanted to end on this one, saying that there's, I think, 3 broad areas that we think we can help, but we are obviously eager to hear what you might think and questions you might have. One is just traditional research. If people on your campuses are interested in doing resource-intensive computation or AI and machine learning, then we can help onboard them, get them access to these resources, and even just the broader access portfolio. If it's instructors who are doing teaching, then many of our interactive interfaces that you've seen could be used for something like that. And finally, we would, I guess, really encourage participation in our REU program. If you have students that you think can benefit from that, we would really love for them to apply. I'll stop there, and I see maybe there's a hand raised, and we'll be happy to take questions.
Looks like Dr. Wall has a hand up.
Yes. Thank you, Rajesh. This is wonderful. It's a lot of technical stuffs when we use this supercomputing. I know I'm using for quite long, but still every time I try to, if I go like 1 week or 2 weeks later, I need to understand what I supposed to do on my Jupyter, from where I have to start. but great. This is really a wonderful opportunity for us. And the reason I like to ask you one quick questions. I've been working like very simple third grader problem. This is explaining people, this is NP hard problem. It's a third grader, just add and subtract. So, and been working almost 2 years, and on similar problem, I'm working for 14 years. Idea is that I want to compress any image or any data into multiple time, like a million time I want to compress. That's kind of ultimate goal of anything. Like, when we get, I work with NASA, I work with NSA, but many agencies right now. The goal is that when we get gigantic data, so how we can come up with some algorithm, we compress many, many times. And somehow I have succeed, but it doesn't work for everything. If I take 1,000 things, definitely it work for 10 things. It's worked very well. I can reduce like trillion times, like compression is a trillion times, but it's not scalable. So that's one issue, but right now I like to ask because I see that you are doing really good work here. So this is like say the third grader problem, like very simple. I ask, like we start, let's say one number 6, we add 1, next number is 7. So create a sequence. And the third number we keep adding like is 1, get 8. And now like next number, just adding 1, right? This is adding thing. So I'll look at 8 and then 9. So rules is here that any new number I generate in sequence should not be derived either by adding or subtracting previous element, previous sequence value. And this is the very interesting, very simple problem, but it's a kind of NP hard problem. So any best computer using supercomputer, I'm able to use so far like 25, 30 elements I'm able to find out. Randomly, we start with any number. I just gave you example. And this is kind of where I'm right now try to work on the AI, what we call large number model. So ultimately, the goal is that anybody working right now, I could not find people working in that area. I give you like the third grader problem. It's impossible to solve. So we are using like post-quantum cryptography. I need to tell that billions, the number at a billionth length, and what number we be using a random number for generating an encryption purpose, like post-quantum cryptography. But in this area, if somebody can help me, like simple up to like 20 number, if somebody can generate, I can take to the next level. So it's simple. I say it's nothing more. It's add and subtract, and current CPU architecture, or it's like so many computational. When you go larger the number, it becomes so many computational process. And but I would really appreciate if you connect with me, some of your team member or who is working with, so I can connect with my team. I'm working with Navy and NASA, and this is kind of research, not confidential project, but where I can talk something I cannot talk, but I can share with any interested researcher who want to explore in this area.
Yeah, that's a very interesting application. Thanks again for describing that. So I have our email address here, anvil@purdue.edu. If you would like to send us an email, but I think more generally with the access portfolio, there's actually because Anvil is more of a CPU heavy sort of resource, but then there are newer resources in the portfolio for more innovative applications. So things like you might know there's a machine at the Pittsburgh Supercomputing Center called NeoCortex that has the Cerebrus chip, which is I think a much maybe more better suited for some of the other maybe matrix style calculations and things like that. So I think beyond Anvil, I would also say it might be a good idea to post in the Access forums, because they have their own message forums, what they call affinity groups. And so there you can essentially get connected to other researchers who are using Access resources. which might be a much broader community than just the Anvil community. So I would say, yeah, if you can send us an email, I can then help connect you to the broader Access community and help you get those posted on there as well.
Perfect. Thank you. I will start now. Okay, thank you.
Thank you.
Are there any more questions before we wrap up everything for this afternoon? All right. So thank you everyone for joining us this afternoon. Thank you, Rajesh and Susanna for joining us to share information about Anvil. Hopefully everyone learned a lot and found some resources that they'll be able to use. And we'd love to also be able to connect you all later on with some students so we can learn more about sharing information about your REU going forward. Thank you for joining us again, everyone, and we will see you next month. Again, if you're in Texas, please join us next week, and don't forget to register for our annual meeting coming up in May. Thank you.
Thanks, everyone.
Everyone.
Thank you.